Hi, kids. Well, here we go. Hi, Mrs. Acker's kids. Hi, Noom's kids. Oh my God, it's midterm time and you have to do work. Hey, you could be taking a midterm right now. Well, I didn't want to do this one first. I want to do this one first. Okay, so you could be taking a midterm right now, but instead you get to hang out with the bald guy. Don't you feel like you won the lottery? For those of you who haven't watched my videos before, shame on you. I'm just kidding. You probably have a life. Just in case you're wondering, I'm going to introduce Mr. Key to you. Okay, for all you noobs out there, somewhere down in this location, somewhere down there, is a button that says subscribe. Can you please do me a favor and hit the subscribe button? I'd love to have some new subscribers. Oh, that's my singing voice. That's sick, man. Oh, I bet you guys miss me singing. It's all about that bass, about that bass, about that bass. Ooh. Man, that was a lot of fun last week. I really had a great time. At any rate, it's midterm week, and you are going to be discussing today composition or composing functions algebraically. Now, you may have had a little practice with this, a slight bit of practice with this, but not a lot. Not a lot. And it's one of those topics that we just sort of glanced over because it kind of wasn't in the Common Core curriculum, and so, but it is in the old curriculum. So yeah, you got to learn it. So let's just get started. So we'll talk about some new stuff. Hopefully this video is not too long and you don't get too bored. If you've ever found yourself falling asleep, just slap yourself in the face. You know. Oh, by the way, have you hit subscribe yet? By the way, every once in a while a commercial is going to pop up somewhere over in that area. I don't know where. I can't really point to it. If it shoots your fancy, click on it. If not, don't worry about it. At any rate, let's get started. Composition of functions. Okay, we're going to talk about some things you already know. You already know how to evaluate functions. Boom. I want to evaluate when x equals -1, so I got to plug that in here for x. So right here, x equals -1. Ooh, that's so fancy. And I also want to plug it in everywhere I see an x. So as Mrs. Noom's kids know, parentheses, Patrice. For all the other normal kids in the building and with normal teachers, we just use parentheses every time we sub in. I know Mrs. Newman likes to say parentheses, Patrice. Oh, wait, hold on. Let me try to say it like her. Parentheses, Patrice. Oh, my God. I can't even get my voice that annoying. But anyway... Oh, sorry, Miss Newman. Love ya. Oh, don't tell my wife. Anyway, so you plug -1 in here. You plug -1 in here. You square -1. If anybody squares a negative and ever ends up with a negative, I'm sorry. You're in the wrong class. -1 squared is +1 plus 4, and the answer is, whoo-hoo, 5 bagger. For my students, if for some reason you notice that I might have made a mistake, yes, contact me. There might be something extra in it for you. All right, so let me use my highlighter pen. We're going to say t is equal to 3. So everywhere I see a t, I'm going to replace it with parentheses and plug in 3. So let's use a new color. How about, I think this is blue. So we're going to plug in a 3. 3, negative parentheses minus 2 parentheses 3 squared. Yeah, that's green, not blue. So S of 3 is equal to negative. Now, this is really just -3 minus 2 times 9, which is equal to -3 minus 18, which is -21. 21. 21. Little German for you. Those who don't know, I speak a little bit of German. Oh my goodness, what do I do here, Mr. Krause? I don't understand. It's not that bad. You guys can handle it. Check it out. Right here. X is equal to 3x. Well, that's really weird. So what we're going to do is everywhere we see an x, we're going to replace it with 3x. So everywhere I see an x, I'm going to replace it with 3x. So I replace it there. Boom. 3x. I see an x. Oops, I don't know why that popped up. I see an x there. I'm going to replace it with 3x. I see an x there. I'm going to replace it with 3x. And then, I know this is a little bit disconcerting. You're not actually going to get a number for an answer. You're just going to get a, oops, I forgot the 3x. You're actually just going to get a new, sorry about that, a new expression or new equation. So 3x squared is really 9x squared. minus 12x plus 1. That's it. Boom, done. All right, moving on. Oh, this one's a little bit more complicated. Now, everywhere I see an x, I got to replace it with this binomial, 2x plus minus 1. You know, the fun thing about math is it just keeps getting harder. Oh, I understand what... Oh, I didn't understand. Oh, now I understand. Oh, geez, no, I don't understand. All right, so it's not that bad. Everywhere you see an x, you're going to put 2x minus 1. For those of you that are noticing that my pen is working better, I got a new tablet. Not a new computer, I got a new graphics tablet. So right now it seems to be working so much nicer. And if I flip the pen upside down, check this out. It's an eraser. Oh my God, I'm like in nerd heaven. All right, so everywhere I see an x, I'm going to put a 2x plus 1. The x gets replaced with 2x plus 1. So I see 1 there. I see a 2x minus 1 there and a 2x minus 1 there. Now, this one's a little tricky. I'm going to start over here. H of 2x minus 1. This thing has to get double distributed. You have to write it twice. Do not distribute the negative just yet. That comes after. That comes at the end. That's really like a negative 1 times this thing. And you know multiplication comes after exponents. So the first thing I'm going to have to do is double distribute. If your teacher uses FOIL, then we're going to have to FOIL it. And then this one I can just, 2x plus 1. I can just distribute here if I want. 6x minus 3. Okay, so let me double distribute this thing. I'm not a big proponent of showing a lot of work, so we're just going to double distribute. 2x times 2x is 4x squared. This gives me minus 2x. This gives me minus 2x. That's minus 4x. And of course, negative 1 times negative 1 is positive 1. And then copy everything else over. Plus 6x minus 3. All right, we're doing okay. Now we have to distribute the negative. So negative 4x squared plus 4x minus 1 plus 6x minus 3. Now, as long as you can add, you're all set. There's only one x squared term. It's right here, minus 4x squared. We got positive 4x and positive 6x. That's plus 10x minus 4. Ka-ching! That's what h of 2x minus 1 is equal to. So, let's go back and take a look at the basic functions of what we're going to do here. I've defined four functions. I've defined f of x, I've defined g of x, I've defined h of x, and I've defined k of x. So I have 4 different functions here. Okay? So, well, I'm just going to show you. I'll just show you. I meant to put it in here and I totally screwed up. So, I'm going to show you. Sometimes you'll see it written like this, and this is red. This right here is red f of g of 10. Another way you might see it written, which is sometimes kind of confusing, is f little circle, I hate that when it happens, f little circle g of x. Now, I'm going to have a kid go, fog x? Oh yeah, I'm kind of foggy about this, Mr. Krause. It's not even funny. This is a composition of functions. We have 2 different functions acting on this thing. Actually, I shouldn't have picked x. I should have picked, in this case, because we're not using x, we're using 10. F of g of 10. Well, what this means is, and I like it written like this better because I think it makes more sense. And let me show you why. The first thing you're going to do is this g of 10. Now, over here, if it's written like this, you're going to use the function that's closest to those parentheses. And you sort of work backwards. This g is first in line closest to the 10. It gets done, and then the f of x. I think it's easier written like this because you're like, oh yeah, I better find out what g of 10 is. So I'm going to go determine what is g of 10. Why do I keep writing x? Sorry about that. What is g of 10? Oops, forgot what the g function is. The g function is take 1/2 parentheses, Patrice, still can't be as annoying, times 10 plus 4. And half of 10 is 5. 5 plus 4 is 9. That's not a big deal. But now what you're going to do is you're going to take this 9 and you're going to replace g of 10 with 9. So now what you have to do is you actually have to do f of 9. And f of 9 says take 3 times 9 and subtract 3. That's 27 minus 3, or 24. So this one is equal to 24. I'll try not to make as big a mess on this one. Let me blow this up so you can see it a little bit better. It's hard to blow up, though. Let me see if I can. Just a wee bit. Ooh, that's a wee bit. Okay. So the first thing we're going to do, I got the functions in there. Good. The first thing I'm going to do is k of 20. So I look at the k function, and the k function says, okay, k of 20 is equal to x, which is 20, plus 4 over 6. Well, 20 plus 4 is 24 over 6, so that's 4. So k of 20 is 4. But now this goes away, and I want to do g of 4. Gee, this is fun, Mr. Krause. I sure wish I could do this every day. I could have off, but have to be here doing work. Shut up, you whiny little... No, I'm just kidding, kids. Oh, my God. I didn't mean to get mean at you. So now what we're going to do is plug the 4 in here. By the way, for those of you that don't know, I'm slightly ADD. I can do like 6 things at once, but never very well. So we're going to plug that 4 into the f function. The f function says, oh my God, no, into the g function. And the g function is right here. It says take half of whatever and add 4. Well, half of 4 is 2. 2 plus 4 is 6. So this whole thing turns out to be a big 6. All right, so this next one says we're going to do h of f of 2. So what we're going to do is f of 2 first. So I go, okay, what is f of 2? Well, if you go look at the f function, and I know it's right there, it's 3 times 2 minus 3. Well, that's 6 minus 3, which is 3. So this gets replaced with a 3. Now I want to do h of 3. Well, h says take whatever is in the parentheses and square it minus 4 times whatever's in parentheses plus 6. Well, this is equal to 9 minus 12 plus 6. And if you do a little bit of work, I think you get 3. Wow, that's weird. 3 again. Interesting. Interesting. All right, let's keep going. G of negative 6. G, this is fun. G of negative 6. Now, if I remember correctly, the g function says take half of x, in this case, negative 6, and add 4. Well, half of negative 6 is negative 3. Negative 3 plus 4 is 1. Now we're going to do k of 1, but I don't remember what the k function is. So I'm going to come back up here and look at the k function. K function, k for Krause. Add 1 and divide by 6. So that's what we'll do. K function. Add 1 to, I forgot, I think it's 4. And all over 6. So my answer is 5 over 6. Don't put that in your calculator. You might get hurt, especially if you're one of my students. I'll hurt you. All right, so now we're going to do f of 1/3. Ooh, Mr. Krause, you're putting fractions in. I don't like fractions. Fractions, one of the fun F words you're allowed to use in class. So just get to work, boys and girls. So f says take 3 times that. So 3 times parentheses minus 3. Well, what goes in the parentheses? 1/3, of course, silly. Silly Willy. 1/3 times 3, I hope you know that's 1. 1 minus 3 is negative 2. Now I have to do h of negative 2. This is composition of functions. I have no idea what the h function says. Oh, that's that pain in the neck one. Squared minus 4x. So we're going to square it first. Minus 4 times that. I forgot the rest of it. Plus 6. All right, and what are we putting in there? What we're putting in there is negative 2. I got to change quick. Negative 2. So negative 2 squared is 4. Negative 4 times negative 2 is plus 8 plus 6. And that turns out to be Y equals 18. Sometimes when you hold it on too long, it doesn't work. Oh my goodness, what is going on here? Now let me show you what this one could look like if it was on another way. This could be written as G of H of K of 8. Now, remember, the closest one gets done first. So the first thing you're going to do is K of 8. Okay, so now I got to figure out what K of 8 is. And K of 8 says, add 4 and divide by 6. So 8 plus 4 divided by 6. That's 12 divided by 6, which is 2. So this thing here gets replaced with 2. I'm doing black. 2. So now I want to do H of 2. Well, H is that one we just did, squared minus 4 times parentheses plus 6. And we're going to put 2 in there. 2. It's a slightly different. It's not negative 2. It's 2. So now I get 4 minus 8 plus 6. And that's 10 minus 8, which is 2. Wow, that's weird. So now I want to do G of 2. Well, G says take half and add 4. So half of 2 and add 4. Half of 2 is 1 plus 4 is 5. So that whole thing here turned out really just to be a big old 5-bagger. And that's composition of functions right there. Let's take it to the next level, though, okay? Let's get to the next level. I might need this room. So, again, if you need help, just rewind and or fast forward. So here's the other way I could write it. So here's what I've got written. I don't necessarily like this way it's written. It's sort of a pain in the neck. So instead of writing it like that, what I'm going to write it like is f of g of x. Now, I'm going to highlight g of x. G of x, I was told, is really 3x plus 5. So what I'm going to do is I'm going to take this 3x plus 5 and I'm going to replace g of x. So this whole thing becomes f of 3x plus 5. Okay. Well, what does the f function say? The f function says take 2 and multiply by whatever's in parentheses and subtract 1. So we're going to put this 2 in here. We're going to put whatever's in there into this parentheses. Excuse me, we're going to take this 3x plus 5, and we're going to put it in here, 3x plus 5, and we're going to subtract 1. Well, now I just got to figure it out, clean it up. 2 times 3 is 6x plus 10 minus 1, so my answer is 6x plus 9. Ka-chang! Oh my God, I so wish I had some Brugger's coffee. For those of you who watch my videos, you know I like Brugger's coffees. But if you notice down here, it's past my bedtime. It's like 9:32. I should be in bed. I'm old. I really am. Not as old as, I'm a lot old. I used to be Newman's teacher. Did you know that? I taught her computer science, sort of. Okay, so f of x is on the inside. So we're going to replace f of x. Well, here is what f of x is. So I'm going to take that and I'm going to plug it in there. So instead of g of f of x, it's g of, okay. What is f of x? X squared minus 5. Okay. So let's see. G says take 6 and multiply it by whatever's in the parentheses. Well, what's in those parentheses is x squared minus 5. So I just distribute. I get 6x squared minus 30. 30. Ka-chang! Wow, that was simple. All right, so this one's written that weird way. I don't like writing. It's driving me crazy. So I'm going to come over here and I'm going to rewrite it as g of f of x. I just think it's easier to see this way. Now I think, okay, oh, why is that g missing? This should be a g right here. Sorry, chillin'. I thought I fixed that. I know I fixed that. That's weird. So f of x is this. So this one's going to get complicated. It's got fractions in it. Ooh, I love fractions, man. Yes. So in here is going to go f of x. So I'm going to do g of 2 over x plus 3 equals 1 over, now, the g function says take whatever's in the parentheses and plug it in there. Well, what's in there is 2 over x plus 3. Now, this, I don't like the way this is written, so I'm going to write this like I was in 5th grade. Well, that's 1 over, what am I, like 80? 1 over 1 divided by 2 over x plus 3. Well, you remember when you divide, you flip and multiply. So this whole thing becomes 1 over 1 times x plus 3 over 2. And 1 times this is just x plus 3 over 2. That's a little complicated. Not bad, though. Are we getting there? I think I got two hard ones. So what I'm asking here is, if I do f of g of x, is that the same as g of f of x? And that's going to become a special case. So we're going to do one then the other. So the first thing I'm going to do is this first one that says we're going to replace g of x. So we're going to do f of whatever g of x is, x minus 9. And f says take 3 and multiply it by whatever's in the parentheses and subtract 5. Well, what's in the parentheses? Sorry. What's in the parentheses is x minus 9. So this becomes 3x minus 27 minus 5, which is 3x minus 32. So now I'm going to do the other one. Now I'm going to replace f of x with 3x minus 5. So the second part says take g of f of x. Well, f of x is 3x minus 5. And sub it in. Well, g is right here. G says just take x and subtract 9. Well, x, whatever's in here goes in here. 3x minus 5. Well, that's equal to, I can just clean it up, 3x minus 14. And that should be a 14. So 3x minus 14. And the question is, are these the same? The answer is no, they're not. Nope, sorry, not the same. All right. Now we're going to do one last thing. I think I got 2 more problems, and this is it. Okay, so composition of functions. Composition of functions. If two functions, f of x and g of x, are inverses, then if I do g of f of x, I should get x. And if I do f of g of x, I should get x. So we got to check this out. Let's see it. Basically, we're going to do what we just did. We're going to do it 2 different ways. So one thing I don't necessarily like the way this one's written. I think it's kind of hard. Maybe not. Okay, so what we're going to do is f of g of x. So in for g of x, I'm going to put this. All right, that's not bad. So what does f of x say? Say it takes 3 times 1/3 x plus 1 and subtract 1. Well, if I distribute this 3 here, I get 1. So I get 1 times x plus 1 minus 1, which is really 1 times x, which is x, 1 times 1, which is 1, 1 minus 1. And then these cancel, and I get equal to x. Now, just because it works one way doesn't mean necessarily that it's going to work the other way. So you actually have to test that. You can't not test it. So here's what we're going to do. We're going to do it the other way. G of f of x. So right here is f of x, and I'm going to replace this f of x with that. So the g function says take 1/3, replace x with whatever f of x is. In this case, it's 3x minus 1. So 3x minus 1 plus 1 in parentheses. So really, remember, this was the x. I replaced it. So this is 1/3 times 3x. Well, this is plus 1 and minus 1. They cancel. And 1/3 times 3x is just x. And then you could say, therefore, g of f and f of x and g of x are inverses. And the reason being inverses. That's some sick spelling right there. And I bet my head's in the way right now. Are inverses of each other. I should have probably brought that over. I'll have to check that out. Make sure my head's not in the way. Okay, one more problem. So we're going to do f of g of x. Gee, this is a lot of fun. Little nose scratch. By the way, haven't hit subscribe, hit subscribe. It's all about that base, Oh yeah. I'm going to replace g of x with this. So I'm going to rewrite this as f of the square root of x minus 1. And the f function says take whatever in there, square it, and add 1, right? Square it and add 1. Well, what's in there? The square root of x minus 1. Well, if I square a square root, those just cancel and end up with x minus 1 plus 1 or x. So far we're good. We've done f of g of x and we got 1. Now we got to do g of f of x. So let me scroll down. We're going to do g of f of x. Well, we're going to replace f of x with x squared plus 1. So the g function says take the square root of f of x. Well, f of x is x squared. I forgot, was it plus 1? Plus 1. And subtract 1. Well, this just becomes the square root of x squared. These two things just cancel each other out. Okay, so I probably didn't need all that. So I probably could have done with a slightly smaller square root. Square root of x squared, which is just x. Therefore, f of x and g of x are inverses. All right, kids. Your job, should you choose to do it, not be lazy. We got enough lazy people in the world, kids. Don't need any more. Is to go through these paltry, how many questions? 12, 13, 12 questions. And finish these 12 composition of function questions. Okay? For my kids, you're going to be turning in both the notes as well as the practice. I'm just going to check to make sure that you've gone through the notes and that you've done the practice problem. So yeah, it's going to take you a little bit of time, but it's fun. You get to hang out with me. Oh my God. And I get to hang out with you. I've missed you guys so much. I should sing a song. It's all about that bass, Hit the subscribe button, hit the like button, comment if you so choose, but don't leave any negative comments. Don't give me thumbs down. I'll give you thumbs up if you know what I'm talking. I mean, just some thumbs up. I'm just kidding. Bye, kids. It's been fun. Have fun storming the castle. Bye.